So the question is, where do I see electric propulsion? I think that's actually that's for sure a good idea for interplanetary travel, particularly since you're going to need a lot of energy once you're on the surface of Mars. So you may as well use that energy while you're in transit to speed up the journey. Yeah, so I think electric propulsion definitely is a good idea. It would be kind of a waste not to do electric propulsion on the way there. The trick is you want to obviously have electric propulsion with enough thrust to matter. That's pretty important. So yeah, I think that's and it needs to be fairly efficient in terms of the energy per newton, like I guess watts of energy to newtons of force. So, I mean, the capsule does have an LVD. It has a, depending upon where we put the lateral center of mass, we can adjust the LVD to as high as 0.3. That gives us a pretty good accuracy. In fact, Dragon landed to within about a mile of its target on the flight in December. There's not an obvious reason, I think, to have more LVD than that. Yeah, nothing that I can think of. And then, the problem with having more complex lifting bodies is that then it gets kind of weird if you want to go to Mars, and Mars has a much lower energy, atmospheric density, particularly in the lower atmosphere. Something that worked well on Earth wouldn't necessarily work well on Mars. It obviously would be completely useless on the Moon. So I think something with a 0.2 to 0.3 LVD is I think good enough, and it's very robust as well. You don't have to worry about maintaining a specific angle of attack. Or something going wrong with your control systems or anything. Even if Dragon control systems totally malfunctioned and were just dead, you still survive because it's going to naturally orient with the main heat shield down. You'll experience higher Gs. You might see 8 or 9 Gs instead of 4 to 5, but that's the only downside. And you can manually pull the chutes. So it's very, very robust in that sense.
Can you talk about the cross-feed technology for the Falcon Heavy?
Sure.
How far along you are in the development of that?
Yeah, so for Falcon Heavy the cross-feed between the outer cores to the center is pretty helpful. It gives roughly 20 to 30% more payload. We have an advantage here in that because there are 9 engines, we can control flow to those engines individually. So the way we would do cross-feed is to basically draw propellant for the engines that are adjacent to the core from the so the engines that, so the center core engine is pulling from its side core on either side. And then we can shut pre-valves to those engines so that it's not sucking it down from the side cores. You can't do this if you've got one engine, or if but you can do it if you have multiple, 9 engines. It's a lot easier. But the cross-feed is really an option for really big payloads. So for customers that don't need the cross-feed, we would not enable cross-feed. Yeah, but it's helpful for missions to either big missions to Mars or missions to the outer solar system. So we're talking to NASA about some potential missions that go out, to 150 or 200 AU. So you're sort of way out past Pluto and stuff. Yep.
Can you expand on the reusability you guys, the successes you've achieved to date and the struggles you've had? I know you advertised early on you're going to use it for. How's that gone? And what's been harder than expected?
Well, this question was just generally, how's it gone with reusability? Well, so far it has sucked, really. I mean, it is extremely difficult. And there's a reason that nobody has invented a fully reusable rocket before. It's super damn hard. But we have learned a lot. We did recover Dragon. So if you sort of think of Dragon as a third stage, we have recovered Dragon, and we recovered it in a condition that you could easily refly it with changing nothing. Repack the chutes and you can fly it again. But the thing is, we can't afford to give a Dragon level of protection to the booster, or the booster would get no payload to orbit. So the real tricky thing here is essentially, constructing a suit of armor that is just exactly tailored to the forces it's going to need to resist on reentry. And those forces are higher than we anticipated. Even for the first stage, because of the trajectory of the first stage, it comes in at a pretty steep angle. So the force is very high. It's basically belly flopping on the atmosphere. So something has to be done to shed velocity. So we're looking at potentially restarting the engines to shed some velocity and give it a more benign reentry. Weighed against increased structural margins and increased and a better thermal shield. It's a tough trade on propellant versus dry mass, and I think we've got something that on paper closes, and we'll see if that turns out to be reality as well.
Spoke about the need for hundreds or thousands of launches per year to get the real economics to serve this, and the moon base and Mars base being able to justify that. And what I'm wondering, for a Mars mission, you don't want that surge to be 2 weeks every 26 months, or the economics break down. You talked a little bit about electric propulsion for non-minimum energy transfers, but how do you see this architecture working so that you can support Mars base with the missions spread over all time instead of in discrete increments?
Right, that certainly is one of the biggest challenges with establishing a self-sustaining civilization on Mars is that planetary alignment. So clearly we need to widen that window. I think maybe if we can get it to maybe 6 months, and obviously you're going to put more payload to Mars if you're at the center of the 6 months than if you're 3 months on either side. And that's something where electric propulsion could be pretty helpful. Another thing you can do is you can obviously launch ahead of time into high apogee orbits, so that there's a whole series of craft kind of in a high apogee parking orbit, waiting for the alignment to occur, and then you kick it over to you give that final kick once Mars is close enough. But it certainly it is a tricky thing, and it's hard to imagine how opening that window more than about 6 months, and even that is pretty tricky from a delta V standpoint.
Would you like to comment on any downside to the transit time to Mars with chemical propulsion as compared with nuclear propulsion?
Well, the tricky thing with nuclear propulsion is getting that reactor up there with a ton of uranium. I think people I think it's going to be hard to convince the public that we should launch large reactors into space because of the potential for a failure spreading uranium on Earth. It's one thing to do sort of a small RTG, but another thing to have a big reactor. I think at some point you could probably construct a reactor maybe on the Moon or Mars, and then have that power. But also, I think when people sort of think about nuclear reactors, they kind of forget how heavy they are, and also the fact that they usually have a source of water close by to drive a steam turbine. So it's when you factor all like a really useful reactor in space and see how much it weighs and compare that to, say, solar panels. Solar panels are pretty good. It's a different story for Mars itself. I think Mars, on the surface of Mars, a reactor would be great because generating all that waste heat would be, you want waste heat on Mars. That's great stuff. Also want anything that's going to cause global warming on Mars that can be shipped. So the question is, what do I think about grabbing the oxidizer on the way through the atmosphere? So, like, if you have a hydrogen-oxygen system, and then having it sort of grab the oxygen on the way. When I've looked at the numbers, it always seemed as though the drag was so significant that it outweighed the benefit of grabbing oxygen. It might be a different thing if air wasn't sort of 80% nitrogen. But when you're grabbing stuff, you're actually grabbing 80% stuff you can't use and 20% stuff you can. And then of course you're sort of stuck in the situation that you can only get a lot of air when there's a lot of drag. And so if you can't really do the high acceleration, and you go past a certain velocity, and the heating rate is too extreme. So you just melt yourself. So I think carrying the oxidizer is probably, even though it seems like, wow, I've got a lot of oxidizer on this rocket, is probably the way to go. Certainly somebody could prove me wrong, but so far I've not seen anything even on paper that would work. So if it doesn't work, at least on paper, then, well, reality is usually worse than paper.